Since the Industrial Revolution, mankind has looked to automation to carry out tasks that a human operator cannot reliably perform, perhaps because they are too involved or too repetitive, or because an autonomous solution is more cost-effective. The military has also adopted autonomous systems to carry out tasks where a human cannot respond sufficiently quickly or where there is a need to keep humans out of harm's way. Having seen the financial savings being made through automation in the civil sector, there is keen interest in how far similar outcomes can be generated for the military. However, unlike a commercial enterprise where the financial bottom line will indicate whether an investment is worthwhile, making the same decision in defence is often much more involved. Research carried out by NATO scientists from the UK, Sweden and Estonia is helping defence planners decide whether to automate and what to automate, taking into account the cost implications and the performance difference between the current conventional systems and an autonomous alternative. In some simple cases, such as logistics planning processes, the automated approach will be a direct replacement for the conventional one, and so the cost benefit will be the overall savings less the whole cost of developing, testing, integrating and deploying the new approach. For the automation of any activity, the value calculation is overall value of automation equals net additional value generated minus net additional cost, which in this case becomes value of logistics process automation equals net logistics savings generated by new process minus process cost difference, where the process cost difference is the cost of the developing, testing, integrating and deploying the new approach minus activity cost savings from cancelling the old approach. However, introducing autonomy into most operational situations is more complex. Let's say a decision needs to be made about whether to add a new reconnaissance UAV to the land force mix. The commander needs reconnaissance and surveillance provided in all weathers, day and night, and against an opposed or unopposed position. The conventional solution is a platoon-sized unit that meets these requirements but takes significant time to move around the battlefield and can only provide a view from ground level. Most current UAV solutions can move speedily around the battlefield and can provide a view from different elevations. They can also meet the opposed and unopposed requirements as well as day and night, but not all weathers. There may also be issues with requirements for command, control, communications, logistics and sustainability. Initially, the analysis would calculate the full costs of developing, purchasing, integrating, deploying, supporting and retiring the UAV system, including all of the supporting troops, equipment and infrastructure. There are a huge number of individual cost elements that make up the cost of buying, introducing into service, operating and retiring a UAV system. These may be broken down into the following categories: system non-recurring costs, hardware production costs, entry into service costs, system in-service costs, system disposal costs. Each of these categories contains numerous elements which may vary depending on the procurement strategy. For example, system non-recurring costs will include technology and system architecture research, technology demonstration, hardware development, system prototypes, system integration, force integration. On the other hand, system non-recurring costs will include market research, technology assessment, candidate system trials, force integration. However, the conventional solution may also be maintained to give all-weather coverage, and so the solution cost is the cost of the current capability plus the full cost of the whole UAV solution. For the automation of any activity, the value calculation is overall value of automation equals net additional value generated minus net additional cost, which in this case becomes value of adding UAV to formation recce equals net value of additional, more timely recce outputs minus whole cost of buying and operating UAV system. Clearly, putting a quantitative value on additional, more timely recce outputs may be challenging. In this case, this solution will be more expensive than the current way of working. So why might it be worth investing in a UAV? There are very significant risks in performing reconnaissance operations. Reducing harm to service personnel is of great importance to NATO nations. Reducing risk is not just eminently sensible, it also reduces personnel cost. Also, the improved speed with which reconnaissance can be undertaken in good weather will be valuable. Different nations have different ways of assessing the value of a system that has the potential to save lives. Ultimately, the decision about whether to use a UAV depends on a judgment being made about the relative values of the change in cost and change in performance that the new system can bring. The costing structure developed by the NATO team allows the change in cost and change in performance to be assessed. Autonomous technology is in the early stages of development. It's clear that even small early steps towards greater autonomy are delivering savings. For example, the use of data analytics within the US DoD has improved the management of fuel, resulting in up to 2% of the overall fuel costs being saved. The NATO scientists also recommend that in addition to system performance data, the full costs of developing, integrating, fielding, supporting and retiring autonomous systems should be captured and shared in a standard form. This will allow all NATO nations to benefit from clearer expectations of the likely costs and performance data for future autonomous systems.